Hey guys, so in today's video we're going to have a look at simplifying basic algebraic equations. We'll do a few different examples to show you some of the common practices that you'd utilize. So let's start out with a fairly simple one. Say we have 10x minus 3x. So here, because we have two components that have the same base term, it's fairly straightforward. The resulting value is 7x. 10 minus 3. 10 of something minus 3 of something leaves us with 7 of something. So that's fairly straightforward. And so have a look at something a little bit more complex now. 9 plus x plus 3x minus 7. So in order to simplify this, we have two different types of components. We have a component that's just a number by itself. Then we have components that have some form of number followed by x. So the first thing that we can do is collect the like components. Let's say those with x and those without x. Then, like in our previous example, x plus 3x becomes 4x. Something plus 3 of something of that same something is going to give us 4 of something. And the leftover components, just the numbers by themselves, 9 minus 7 is just 2. So that's the answer of this simplification, 4x plus 2. So you can see it's fairly straightforward. You just need to apply the same process to the different terms. Now, let's have a look at an example which uses multiplication. So here, we have two different base values, and each one has a different number out the front. So when multiplying two different variables, we simply represent them as here, f times n can be represented as fn. And out the front, we just multiply these two numbers together. So we have 2 times 4, which is 8. So our answer becomes 8fn. Another way to look at this is that there's a missing or a hidden multiplication sign between each of these components, which leaves us with 2 times f times 4 times n. And essentially we're just putting it all together, which is why I have 2 times 4 outside fn, and that's why we get 8fn. Next example, let's have a look at 8s cubed plus 8s cubed times 2s squared. Here we're going to result with, using the same process as before, 16 out the front. And now we need to use one of our index laws that I've covered in a previous video. S times s to the power of 3 times s to the power of 2 is s to the power of 3 plus 2. So our answer here is 16 s to the power of 5. Next we have 20x divided by 15x. So here we can represent this as 20x in the numerator of a fraction, 15x in the denominator of a fraction. We can cancel out both the x's, and we can also see that there's a common multiple in 20 and 15 of 5. And 5 goes into 20 4 times, and 5 goes into 15 3 times. So we're left with 4 and 3, and the x's of course disappear. So you can see simplifying algebraic equations uses a few of the different techniques that you've used over the years, and sort of puts them all into practice in different ways to get the equation as simple as possible, or that makes it easier to solve the rest of the question, or to move that number into another part of the process. Let's have a look at one more example. Negative 24 d5 w6 z divided by 36 d cubed w3. So of course, keep in mind that any number is just a variable and can be interchanged with any other symbol to represent that same variable. So don't get too caught up with the numbers, or with the letters, sorry. So here, let's just represent this equation as a fraction to make it a bit easier. 36 d cubed w. So here we can see that, let's first tackle the numbers. Because we only have one term in the numerator and one term in the denominator, we're allowed to cancel different components. So for the numbers, we can see that we've got a common multiple of between 24 and 36, common multiple of 12. 12 goes into 24 twice, 12 goes into 36 3 times. So we're left with 2 in the numerator, 3 in the denominator. And now let's have a look at cancelling some of our other components. D to the power of 5 in the numerator, d to the power of 3 in the denominator. So we can cancel out 3 d's in the denominator, which leaves us with 2 d's in the numerator, or d squared. And I've left off the 3 here, so there you go. And doing the same with w leaves us with 3 w's in the numerator. And of course there's no z in the denominator, so it remains. So this is our answer here, or if we wanted, we could just represent it with the fraction across the whole value. But that's it. That's simplifying a few different, simple, straightforward algebraic equations using a combination of different simplification techniques. Hope you enjoyed, and leave any questions in the comment section below. Thank you. Bye.